All right, so today we're going to dive into something a little bit different.
Oh,
Yeah, we're going to be looking at a DIY project, and we're going all the way back to 1994.
wow.
Yeah, we're using this article from Home Power Magazine by Richard Perez, and it's all about building your own 12-volt engine generator.
1994.
Yeah, it's pretty cool to see what these early renewable energy folks were up to.
Apparently, yeah.
So get ready, we're going to learn about battery equalization, turning old car parts into something totally new, and just embrace that whole DIY spirit.
I love it. So, what was Perez's goal with this project? Was he trying to go completely off grid?
Well, not exactly. He was more focused on creating a reliable backup power source.
I see. So, like a safety net for when your primary renewable sources aren't enough?
Precisely. Especially for those living off-grid where a power outage could be a real problem.
That makes a lot of sense, especially back then when renewable energy systems weren't as reliable as they are now.
Right, it's like having peace of mind knowing you've got a plan B.
Yeah, for sure.
Now, one thing that Perez really dives into is this concept of equalizing charges.
Oh, yeah, that's an important one.
So for those who might not be familiar with it, can you explain what an equalizing charge is and why it matters?
Sure. So basically, an equalizing charge is like a controlled overcharge of a fully charged battery.
Okay, and that sounds kind of counterintuitive, doesn't it? Like, isn't overcharging bad for batteries?
You would think so, right? But in this case, doing it occasionally can actually be really beneficial for your battery's health and lifespan.
Really?
Yeah. You see, each battery has multiple cells, and they don't always charge and discharge at the same rate.
Oh, so some cells might be lagging behind.
Yeah, exactly. And over time, that can lead to imbalances, which reduce the battery's overall performance.
It's like a team of runners where some are getting tired and slowing down the whole group.
I like that analogy. That's a good one. And the equalizing charge is like a reset button.
Bringing everyone back up to speed?
Exactly. It maximizes the battery's capacity and extends its life. And it's not just for off-grid living either.
Oh, so this applies to like our phones and laptops too.
Absolutely. Anything with a rechargeable battery.
Wow, that's good to know. I'm definitely going to keep that in mind.
It's a good little trick to get the most out of your batteries.
Definitely. Okay, so back to the engine generator itself.
Yeah.
Perez did something really clever with the parts. He talks about using car alternators.
Oh, yeah. That's one of the coolest aspects of this project.
What makes that so ingenious?
Well, instead of trying to source these expensive specialized components, he realized that car alternators were a perfect fit.
Ah, because they already generate 12-volt DC power.
Exactly, which is exactly what you need to charge a battery bank.
Makes sense.
Plus, they're readily available and relatively affordable.
So he's basically turning everyday car parts into energy independence tools.
Exactly. It's brilliant.
I love that. Okay, so he doesn't just slap any car alternator on any engine, though, right? He talks about sizing and matching components.
You're absolutely right. Getting the right balance between the engine and alternator is crucial.
Why is that so important?
Well, for efficiency and for the lifespan of your system.
Okay.
Perez provides some guidelines on how to match engine horsepower to alternator output based on the capacity of your battery bank.
I see.
So for example, if you have a 700 ampere hour battery bank, like you did initially, a 35 ampere alternator paired with a 3 horsepower engine would be a good fit.
So you wouldn't want to put like a tiny engine with a huge alternator.
It'd be like trying to tow a giant trailer with a compact car.
You might get it moving, but it's not going to be pretty.
Exactly. And speaking of performance, Perez actually experimented with different engine brands.
Oh yeah, which ones?
Honda, Tecumseh, and Briggs & Stratton, just to see how they held up over time.
Interesting.
And you know what he found? The Honda engines, especially the G40 model, were the real workhorses.
So they lasted the longest.
They did. He got over 5,000 hours of runtime out of them without major issues.
Wow. Compared to the others.
Yeah, the Tecumseh engines averaged around 800 hours.
Oh, wow. Big difference.
Huge difference. And the Briggs & Stratton were even less, around 600 hours.
That's interesting.
It just shows that sometimes spending a bit more upfront for quality can save you money and headaches in the long run.
A good lesson for any DIY project, really.
Absolutely.
Now, there's another detail that Perez emphasizes that might seem small, but it's super important for the generator's performance.
What's that?
Pulley alignment.
Ah, yes. That's where his attention to detail really shines through.
He stresses that making sure the engine and alternator pulleys are properly aligned is crucial.
Yeah, if they're not aligned, you'll get rapid belt wear.
And that can lead to all sorts of problems.
It can. It's one of those things that can make a big difference in how smoothly and efficiently the whole system runs.
It's like anything. If the foundation isn't right, the whole thing can fall apart.
Exactly.
Okay, so now we're getting to the part where things get really interesting.
I was wondering when we'd get to this.
The control systems for the generator.
Yes. This is where Perez really gets creative.
So first, he talks about why you can't just use a standard car voltage regulator for deep cycle batteries.
Right. Car voltage regulators are designed for car batteries, which are different from deep cycle batteries and how they're used.
How so?
Well, car batteries are only really cycled a small amount,
Right.
but deep cycle batteries are meant to be discharged much more deeply.
And that affects how they need to be charged.
Exactly. So a car voltage regulator would try to force the alternator's full output into the battery right away.
And that's not good for the battery.
Not ideal. It's like trying to fill a bathtub with a fire hose.
Not a good idea.
Nope. Plus, car regulators usually max out around 14 volts.
Okay.
And to properly equalize a battery bank, you need to go higher, like over 16 volts.
Ah, I see.
So Perez came up with two alternative solutions, a resistive field controller and an electronic field controller.
So let's start with the simpler one, the resistive field controller. How does that work?
It's actually a pretty simple concept.
Okay.
You basically put a variable resistor called a rheostat between the battery and the alternator.
And that controls the alternator's output.
Yeah, by adjusting the resistance, you can control how much current flows to the alternator's field winding.
I see.
More resistance means lower output and vice versa.
Like a dimmer switch for your generator.
Exactly.
That's pretty cool.
Yeah, and Perez even mentions using a heating element from an old electric stove as a resistor in his early experiments.
Really?
Yeah, he was really resourceful.
That's amazing. But this method has some drawbacks, right?
It does, mainly that you have to constantly monitor the system.
Especially when the batteries are full.
Right, to make sure the voltage doesn't get too high.
Okay, so it's a good option if you're willing to be hands-on. But
Yeah.
for those who want something more automated, there's the electronic field controller.
Right, that one is a bit more complex, but it offers automatic regulation of both the amperage and voltage.
Nice. So you can just set it and forget it.
Pretty much, you set the desired charge rate and the maximum voltage, and the controller handles the rest.
That sounds way more convenient.
It is, and for those who are comfortable with electronics, Perez actually provides the full schematic for this controller in his article.
Wow, that's some serious DIY dedication.
It really is. He doesn't just tell you what to do, he empowers you to understand the how and why.
It's like a masterclass in DIY electronics.
But we'll dive into the details of that electronic field controller design after a short break.
So we're back and ready to dig into the heart of that electronic field controller.
Yeah, the one Perez actually lays out the whole schematic for.
Oh yeah, he doesn't hold back. It's all right there in the article.
Really impressive for a DIY project from back then.
It is. He even uses some classic components that are still around today.
Like what?
The LM723 voltage regulator, that's a classic.
And what does that do exactly?
Think of it as the brains of the controller. It sets the voltage you want for your system.
Ah, okay, so it's making sure things don't go haywire.
Right, keeping the voltage steady.
Makes sense.
And then there's the NE555 timer chip, another super versatile component. I've heard of that one, but what's it doing in this circuit?
Well, it's creating what's called a pulse width modulation signal, PWM for short.
PWM, okay, and what's that all about?
It's basically controlling how long the alternator's field winding is energized.
By varying the width of these pulses.
Exactly. You can really fine-tune the alternator's output that way.
And that's how you get that precise control over the amperage and voltage.
Precisely. It's like having a super fine-tuned dimmer switch for your generator.
It's pretty cool, so it's constantly adjusting things.
It is, keeping everything running smoothly.
But what's even more impressive is that Perez doesn't just throw the schematic at us. He explains his thought process.
Oh yeah, he goes through each component, why he chose it, how it works.
It's like he's holding our hand through the whole design process.
Exactly. It's a great learning experience, even if you don't plan on building it yourself.
Absolutely. It's that DIY spirit, sharing knowledge, empowering people.
I love that. But let's imagine for a second we're building this today, in 2024, not 1994.
What would be different?
Oh man, the possibilities are endless. We have so many more options now.
Like what?
Well, for starters, microcontrollers, programmable logic devices, those are game changers.
So we could make the whole system even smarter.
Oh yeah, imagine a setup where the engine generator starts and stops automatically based on your battery's charge.
Or even integrates with your other renewable energy sources.
Exactly, a truly smart backup power system.
That would be amazing. And what about the batteries themselves? Any upgrades there?
Tons. We could ditch the lead-acid batteries and go with lithium-ion or lithium iron phosphate.
What's the advantage there?
They're more compact for the same amount of power, and they charge way faster.
So the engine wouldn't have to run as long.
Exactly. Less noise, less fuel consumption.
That makes sense. And what about the overall design?
3D printing, CNC machining, those open up so many possibilities.
We could create custom mounts, enclosures, make the whole thing super sleek and compact.
Absolutely. It would be like a high-tech makeover for Perez's classic design.
I love it. But even with all these upgrades, there's something so elegant about the simplicity of his original design.
You're right. It's a reminder that sometimes the most effective solutions are the most straightforward.
And that DIY spirit, that's timeless. It's about taking control, being resourceful.
Absolutely. It's a way of thinking, a way of approaching problems.
I'm curious, though, what are your thoughts on the bigger picture here, this whole idea of DIY energy solutions?
Well, I think it speaks to this growing desire for energy independence, for resilience.
Like taking control of where your power comes from.
Exactly. And maybe even reducing our reliance on these massive centralized power grids.
Especially in a world where energy reliability is becoming more and more of a concern.
You got it. It's about having options.
And it's empowering, knowing that you can create your own backup power if you need to.
It is. It's about self-sufficiency, resourcefulness, tapping into that pioneering spirit.
I love that. Okay, before we get too carried away, is there anything else from Perez's article that we should touch on?
There is one crucial aspect we haven't addressed yet, the environmental impact.
Ah, yes, that's an important consideration.
We've been talking about all the benefits, but we need to be realistic about the environmental consequences.
So how green is this solution, really?
Well, it's not perfect. Burning fossil fuels will always have an impact.
Right.
But the extent of that impact depends on a lot of factors.
Like the type of engine, the fuel you use, how often you run it.
Exactly. And there are ways to minimize that impact.
Like what?
Using biodiesel or other alternative fuels, exploring catalytic converters, even capturing the waste heat from the engine.
So it's about being mindful, finding that balance between practicality and sustainability.
Exactly. And those are the kinds of questions we should all be asking ourselves.
Yeah, as we strive for energy independence, we need to consider the bigger picture.
Absolutely. It's about making informed choices and being responsible.
Well said. This whole conversation has really got me thinking.
Me too. It's amazing how relevant this article from 1994 still is today.
It really is. The technology might change, but the underlying principles remain the same.
And that DIY spirit, that'll never go out of style.
Absolutely not. I think we've covered a lot of ground today.
We have, from the nitty-gritty technical details to the broader philosophical implications.
But as always, the journey doesn't end here.
Right. We've given you the tools, the knowledge. Now it's up to you to explore.
To ask questions, to tinker, to maybe even build something amazing.
And who knows, maybe you'll be inspired to share your own DIY adventures with the world.
We'd love to hear about them. So until next time, keep that DIY spirit alive.
And keep those creative sparks flying.
That's a wrap. Welcome back, folks. You know, we've covered a lot of ground, haven't we?
We have delved deep into the nuts and bolts of this whole engine generator project.
Yeah, from scavenging those car alternators to the elegance of Perez's electronic controller design.
It's pretty remarkable how much ingenuity is packed into this one article.
It really is. You know what strikes me?
What's that?
This whole thing feels timeless. Like, even though it's from 1994.
I know what you mean, the DIY spirit, that yearning for self-reliance that never goes out of style.
Exactly. It's like he's not just giving us instructions for a generator. He's giving us a blueprint for a mindset.
A way of tackling any problem, any challenge with that can-do attitude.
Absolutely. And, you know, thinking about it, if we were to build this today, in 2024.
Oh, yeah. What would our 21st century version look like?
Exactly. I mean, the possibilities are pretty mind-blowing, right?
They are, with all the tech we have now.
So let's throw it out to our listeners. What features would you prioritize?
Yeah. What would your dream engine generator look like?
Would you go all in on automation, sensors, microcontrollers, the whole 9 yards?
Or maybe you'd focus on making it super quiet, super compact, perfect for a tiny apartment or a mobile workshop.
Maybe even experiment with some alternative fuels or some sort of heat recovery system to really minimize the environmental impact.
This is where your creativity comes in, folks.
We've given you the foundation, the knowledge. Now it's time to let your imagination run wild.
This is what the DIY spirit is all about, taking what you've learned and making it your own.
Exactly. So as we wrap up our deep dive into the world of DIY engine generators,
It's been quite a journey, hasn't it?
it has. We've explored battery equalization, those clever car part hacks, even peeked into the mind of a true DIY electronics wizard.
But more importantly, I think we've glimpsed the power of human ingenuity.
That drive to create, to solve problems, to take control of our own needs.
And that's something worth celebrating, worth nurturing.
Absolutely. So keep learning, keep exploring, keep that DIY spirit alive.
And who knows, maybe you'll be the one inspiring us with your next amazing creation.
That's it for this deep dive, folks. Thanks for joining us.
Until next time, keep those creative sparks flying.